Okay, today we're going to continue our lesson 22, but we're going to be talking about the tangent identities today. So for the sum of the tangent, it's very simple. We take the tangent of the first angle, add it to the tangent of the second angle, and notice that plus sign agrees. Now we're going to have a denominator, which we didn't have denominators yesterday, but it's going to be 1. Notice the operation changes, and right here the tan of the first angle is multiplied by the tan of the second one. Here they're being added, here they're being multiplied. Now for the difference, there's one change. It's plus minus. This time for the difference, it's minus plus. So I'm minusing their tangents, and in the denominator I'm saying 1 plus the product of those tangents. So question or example 7 says find the tangent of 255 degrees. Now I'm thinking about 255 is 210 plus 45. But you could do that in different ways. I mean 120 plus 135 would be 255. So it doesn't have to be the way I'm breaking them apart. That's just how I thought of it. So when I'm trying to find the tangent of 255 degrees, that's me trying to find the tangent of 210 plus 45. So my first angle, or my angle U, is the 210. My angle V, or my second angle, is that 45 degrees. So since this is a sum, I'm going to have a plus in the numerator and a minus in the denominator. Tan of the first angle plus tan of the second angle. 1 minus the tan of the first times the tan of the second. Well, the tan of 210 is square root of 3 over 3. Tan of 45 is 1. In the denominator, it's 1 minus square root of 3 over 3 times 1. Now, if I want to add these expressions, I'm going to have to get a common denominator, and that would make sense to use a 3 as my denominator. So as I move over, you're going to see that I've changed this 1 to 3 over 3. I did the same thing here in the denominator. I changed 1 to 3 over 3. And of course, multiplying 1 by that would give me minus the square root of 3 over 3. Now, since I have a common denominator, I can add my numerators. Square root of 3 plus 3 over that 3. 3 minus the square root of 3 over this denominator of a 3. So now I have a fraction over a fraction, which y'all understand is a complex fraction. And I will go over here now and multiply by the reciprocal. Dividing by a number becomes multiplying by its reciprocal. So I see here that my 3's would cancel, and I would be left with this numerator, square root of 3 plus 3, over this denominator. But we know that we cannot leave a radical in the denominator, so we would rationalize. For a minus, we have to multiply by the related sum. So this will change into the square root of 3 plus 3. So follow me. I'm doing FOIL here. So square root of 3 times square root of 3 is 3. Square root of 3 times 3 makes 3 of those. 3 times the square root of 3 is 3 square roots of 3. And 3 times 3 is 9. Now if you remember, when you are rationalizing, your middle terms are going to cancel because this is going to be a positive 3 square roots of 3, a negative square root of 3. So it's always the first expression squared. Square root of 3 times square root of 3 would be 3, minus 3 times 3 is 9. Now in my numerator, I have a 3 and a 9, which would make 12. Then I have 3 and 3 more, which would make 6 square roots of 3. 3 minus 9 would be a negative 6. Now I'm showing you how I'm going to take this 12 plus 6 square roots of 3 and factor a 6 out of that. When I factor a 6 out, I'm left with 2 plus the square root of 3. These 6's would cancel, so negative 6 into positive 6 would leave me with a negative 1 in front of that sum, but I will go ahead and distribute that across. And that becomes negative 2 minus the square root of 3. So I said in today's introduction to our lesson that the rules are not complicated to me for tangent, but the arithmetic of simplifying can get a little bit tiresome. Now we're supposed to do 7 pi over 12, and we're supposed to think of it as a difference. Anytime we have a 12, we know that that is not one of our unit circle angles. And I'm looking for two numbers that when I subtract them, I would get a 7. And I'm thinking, well, 10 and 3 would work. I like 10 because 10 and 12 would both reduce by 2. 3 and 12 would both reduce by 4. So that would work. So now I have the tangent of 5 pi over 6 minus pi over 4. The tangent of 5 pi over 6 minus the tangent of pi over 4. 1 plus the tangent. So it's now the tangent of 5 pi over 6 is a negative square root of 3 over 3. Minus 1. 1 has to turn plus. This is a negative square root of 3 over 3 times 1. Change my 1 into 3 over 3 so that I can actually subtract. So that becomes a negative negative square root of 3 minus 3 over 3. Turn this into 3 over 3 plus a negative square root of 3 over 3. So that becomes 3 minus the square root of 3 over 3. Now, in order to simplify this complex fraction, we turn it into multiplying by the reciprocal. So the 3's will cancel here, and I have a negative square root of 3 minus 3 over 3 minus the square root of 3. And this gets kind of hairy because I have so many negative signs in here. What would I rationalize with? I would use 3 plus the square root of 3 over 3 plus the square root of 3. When I use my FOIL method, I will get negative 3 square roots of 3 minus negative 3 minus 9 minus 3 square roots of 3. In the denominator, I will have 9 minus 3. Then I will simplify. I have a negative 3 and a negative 9, which makes a negative 12. Negative 3 and negative 3 square roots of 3 makes negative 6 square roots of 3. This time when I subtract, I get a positive 6. I will factor out my 6 and get negative 2 minus the square root of 3. Divide out my 6's or reduce there, and I get negative 2 minus the square root of 3. Now these two answers were the same, but the process of getting there is totally different. These two angles are angles. This one would be in the 4th quadrant, this one would be in the 2nd quadrant, and they would be angles that have the same tangent value. So that's why they came out to be the same answer. Because one's in the second, one's in the 4th, but they're both going to be negative tangents. Now let's look at the other page that we looked at yesterday, where we had a couple of problems that had to do with tangent, and I said we would look at those today. So I have the tangent of 20 plus the tan of 35 minus. That's my clue right there. I'm obviously just working with tangent, and this is a sum. Whatever the sign in the first numerator is, that's what we're doing. So that's the tan of 20 plus 35. So that would be the tan of 55. This time, angle, second angle, first angle, second angle, subtraction, change to plus. So this is a difference. So this time it's the tan of 82 minus 53, which would be equivalent to the tangent of 25 degrees. Now tonight you are going to go back to that page 468, and you're going to work the problems that we left out last night. These problems have to do with tangent. So you're going to go back over there and do those 6 problems for tangent. And then I've also included a lesson 22 worksheet on sum and difference. And this is reviewing both sine, cosine, and tangent. And these you will take your expression and simplify it into a single expression. And I put room there on your answer sheet so you can just put your answers in those blanks. Number 7 is a review problem. You need to go back and think about how you would answer that. Then on the back, here are some true-false questions. They're asking you, would you find the cosine of 62 as simply the cosine of 20 plus 42? Now, make sure you're paying attention to what the statement is saying. Don't get confused. So those are blanks for your answer true-false questions there. And then at the bottom, I just have 2 other review questions. It says, use the sum or difference identity to find the sine of 11 pi over 12 and to find the cosine of 285.